Alright, so now we're going to talk about permutations. And I'm going to use some famous mathematicians, Euler, Gauss, Pascal, and Fermat, to help illustrate this. And your book uses this notation, although I don't particularly care for it. I like this notation better. And I'm going to explain what happens here. If you're just looking for a permutation, it basically means how many different ways can you arrange some objects. And if I just said you have 4 people arrange them in different ways, it'd actually be 4 factorial, which is 4 times 3 times 2 times 1, which is 24 different arrangements. I wanted to make that very clear. These are arrangements. And so the order the order does not matter here. If you have Euler in line and then Gauss, or Gauss in line and then Euler, that's perfectly fine. Let's say you want to order them taking 2 at a time. That's what this means. You have 4 people, you're going to arrange them 2 at a time. And so you'd end up with Euler and Gauss, Euler and Pascal, Euler and Fermat, Gauss and Euler, Gauss and Pascal, Gauss and Fermat, Pascal and Euler, Pascal and Gauss, Pascal and Fermat, then Fermat and Euler, Fermat and Gauss, and Fermat and Pascal, which is 1, 2, 3, 1, 2, 3, 4, which is 12. Well, kind of a pain in the neck to have to do that all the time, especially if your numbers get big. So we say, your book says P42. You can already hear the disdain in my voice. I like to say 4P2. And so basically, this is your N, and this is your R. And so you say 4 factorial over 4 minus 2 factorial, which is 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1. And look at that. You get 4 times 3, which is 12. I'm going to show you something else that's kind of cool. Let's say you had, this is partitions, and let's say there's 20 workers. And you need to put them into groups. Let's say 6 of them had to make sandwiches. I'm not sure if I spelled sandwiches right. 4 of them had to prepare tables. And 10 of them had to actually work. What you could do is you could say, all right, well, I have the 20 workers, but I'm going to break them into these groups, 6 factorial, 4 factorial, and 10 factorial. And when you do that, you'll actually get some kind of answer. You'll have to do that on your calculator. Remember, if you do this on your calculator, you can do it all at once, but you have to use parentheses. That's kind of it for permutations. Permutations are pretty easy. The one thing I do want you to realize here is Gauss and Euler, which is here, is the same as Euler and Gauss, but because it's a permutation, we don't actually care about the order. It doesn't make much of a difference. And that's it. We're going to talk about combinations in the next video, and the order does make a difference.